So now let's talk about IT security. Now that you understand some IT, and we'll build more into it later on. Now, IT security, what is IT security? It's the same thing as cyber security or information technology security. Okay, it's the process of protecting information system, meaning computers, which is made up of applications. Applications are the business software. Business software, example of those, are SAP or Financial Microsoft. Now, if you work in a bank, your employer will have a banking software for processing customers' transactions. If you work in retail, like Walmart or Target, your employer will have a retail software for processing customers' transactions. Those are applications. So we want to protect those applications. These are just examples. SAP, Oracle, Financial, Microsoft. These are enterprise resource planning systems. They are large systems. They help organizations plan their resources, enterprise resource planning, but they have modules. They have modules for different departments, modules for marketing module, finance module, HR module. So they help organizations plan their resources. That's what I call enterprise resource planning. So you're still using, you have different modules of SAP connected together. You're still using SAP, and will serve all your different departments, using different modules. Now, these are large systems. You have other regular systems like Momentum, Federal Customized, Oracle Financial, IDMS, Identity Management System, Physical Access Control Service System, PACS. So these are examples of business software. But we apart from this ERP system that have brand names, which are really popular, the name of system don't really matter because they are named after their use. From this IDMS, Identity Management System, I know used to create user IDs. It's called Identity Management. From this Physical Access Control, I know this one used to create badge access because Physical Access Control. So it could be, these parts could be SAP by brand name, was named this because that's what it's used for. Access control. So that's why we don't need to worry about the names of system applications or their name after their use. So we want to protect those applications and the IT infrastructure they run on. The IT infrastructure like operating system. The business application cannot run on their own. They need support. They need infrastructure to run on. The IT infrastructure examples are operating system like Windows 10 or Windows 11. That's going to be booting it up. Database that's going to collect data from the application and store it away till needed. The network devices are going to keep it safe on the network. For instance, you have network devices like firewall here, your control panel here. Firewall is on. Keeping the application safe on the network. So those are IT infrastructure that support the applications. We want to protect the applications and the IT infrastructure underlining them and supporting them. We want to protect them from unauthorized access or disclosure. We don't want people accessing them without authorization. We want to protect them from unintended change. People should not be able to make changes to it without authorization. We want to protect it against unplanned events that will take it offline. So that will make it unavailable. We want to protect against those. So all we're trying to do is to achieve the overall security objective of maintaining the confidentiality, integrity, availability of that system, called the CIA. So at any given time, we are trying to achieve the confidentiality of the system, which is against unauthorized access, integrity of the system, maintain integrity of the system against authorized changes, or make it available, maintain the availability against unplanned, offline. So we're trying to achieve at least one of those at any given time. That's the cornerstone of cybersecurity. Our security objective is to maintain TCIA for the system and the information contained on that system. That's what we're trying to achieve. Protect the system and maintain the CIA. Okay, very important to make sure people don't have access to it. To make sure people don't make authorized changes to it. Okay, to make changes to a system, it goes through a process. Make sure the system is available. It goes through a process. Okay, so for instance, if this Google is a system, uh, Google is a complete system. Now, it's just available online. There's a process to change it, to make sure it has integrity, we can trust in the content. They have to make, if you want to make changes to it, they have to go through a process. Somebody might say, we want this Google to be Google. Let's say for business reason, it's necessary to move G to the end with space at Google. It has to be requested officially and with justification why it has to be like that. And then you go to management person. Management person has to approve it if it makes sense for business need. And once the management person approves it, you go to developer queue to do the programming change. Now, if it's a business analyst at that company, you go to the business analyst first. The BA will look at the request, make sure it makes sense. They might get back to the user that made the request just to make sure they capture all the information needed. And then they now pass it on to a developer. Developer is a programmer that will do the programming change. Once a change has been approved, if it's not approved, you go back to requester with comment from management. Or if it's approved, it goes forward to a developer's queue. Now, a programmer will just, they do programming, they understand programming language. They will go to the programming interface of the system. This is a production system, prod. There's another copy of the system called development, dev. There's another copy called test. But the prod is is the one that everybody uses, production copy of the system. But the developer will go to the development copy of the system. We'll look at the production as well, but it's not, but only developers are there. Now, this is user interface. They'll go to the programming interface. This is user interface. Interface is how you connect to a system. It's what the users uses. But the programming interface of the system, if I want to see it, and right click and do use page source. It will take you to the source code of this system. For instance, I'll see the source code. This is the program behind this thing. This is the user interface. This is the programming interface. Developer will go to the programming interface of the development copy of the system. This G that you're seeing there might be in line 9 here. They cut it out from here, move it to like this line, paste it here. And as they're moving it from the programming interface, you'll see it moving from the user interface. They'll move it to the right place, and when it's positioned well in the user interface, they will now copy the updated program. This system has been changed, but the program has been changed. You copy the program, the updated program, put it in test environment. So test environment will now be showing Google instead of Google. They will now send a link to whoever made a request to click the link, and it will take them to the test environment of the system and see if that's what they asked for. When they click the link, it will take them to the test environment. You'll see it's showing Google. They will not see the programming change. They will only see the user interface. Now, it will show G at the end, Google, and then they'll say, hey, yeah, that's what I asked for. They will use that comment. You just did a test. The user has already did a test. The test has passed. You now use that comment to get approval from management to move the change to production. During those, when management approves it, during those 90 hours, they say you can no longer log into the system because they already copied the updated program into the production system. And then it is then when this change now reflects in production. During those EOD, end of day processing period, where you can no longer log into the system. So when people come to work the following day, you now see it's now spelling Ublek. The change has happened, but see, it goes through a request, approval by management, test, and approval to move to production. And those are done by different people. So when that is done, the system has integrity. If somebody just goes and makes the change without approval, the system does not have integrity. You cannot trust that system. Okay, so that's what we do in cyber, and we work with other people. We are cybersecurity stakeholders. We have other people who also assigned to that system, like developer, like a business analyst, like a program, like a DBA, system administrators. They also assigned to the system. We are focused on security of that system. They are focused on other things. The programmer is focused on programming. The DBA is focused on database on that system. But we are all stakeholders of that system. So, but we protect the system. Now, our projects are such that we, we perform security control testing. There are some protection we expect on the system. We call them controls. We need them. We'll test it, make sure they are there on the system. We do vulnerability scanning, scan the system for vulnerabilities. We use tools to do that. We hack the system. We do penetration testing. We hack the system. If you can hack it, we know the bad guy can hack it as well. So we want to fix the problem before the bad guys detect them. We do incident management. We monitor for security incident and keep the system safe, on our network safe. If we monitor the network for attacks, and if you see any sign of attack, we remove the attacker from our system. That's system management. Okay, and we do that to determine if the controls or safeguards. We do all those things to make sure that the controls on the system are working. Controls are safeguards against risk. Risk is what could go wrong in the system. We want to make sure they are designed properly, are operating effectively or consistently. Those controls are there. For instance, we expect there will be password protection. We expect that there will be firewall on the system. Those are controls. They are safeguards for the system to keep it safe against what could go wrong or risk. To make sure those safeguards are there, the controls are there, operating consistently all the time to achieve the confidentiality, integrity, and availability of the system, CI of that system, and the information on that system. So when we do control testing, we get evidence from system administrators. The system administrators are the ones that turn the system on and off. They maintain the system. We just to get evidence from them to make sure the controls are there. For instance, we ask them, do you have firewall on this system? They say, yeah, we have firewall. So show us the proof, show us the evidence. They will log into the firewall section of the system. They show us, see, firewall is on. They give us this screenshot of this as a proof. So, and if you see the firewall is on, we pass down that control. It's a list of control that we check on the system when we are doing security control testing. We check it. If it's evidence support that they are there, we pass it. The evidence support that they are not there, we fail it and we put it in our reports. We put it in our report as a control failure or security weaknesses. Security weakness they need to fix. System administrators are the one that will fix those. If it happens in the database, database administrators are the one that will fix them. So they'll give us this evidence. They give us a screenshot. How do they capture that? They can press the print screen on their computer, keyboard, PRTSC, mine is beside my space bar. If I press it now, it will freeze my screen. I can highlight the part I want to capture. Now, see, it's frozen my screen. I can just, maybe I want this part. I just highlight that part. So it's already copied that part that I highlighted. I can just paste it on a Word document. Right click and paste it. That's it. That's how they paste it and send it to me. The system administrator will just do that. And so if I see firewall is on, I pass that control. If it's off, I'll fail it. If there's no evidence, I'll fail it. Okay. So, or I can use the snipping tool. It's a free tool for capturing screenshot on Windows. Call it snip. You can just search for snip. Comes on snipping tool. It works like a print screen. And you come up. That's right. There's no new. I can use to capture. I can say, I only want to capture this part. I like that part only. Or maybe it's just this part that shows the on button. I like that part right there. Now paste it in the Word document. Right click paste. Or I can do Ctrl V to paste. Ctrl V, Control C is to copy. Control C is to cut. Control V is to paste. Right there. That's evidence. That was on. So we do that. We get evidence. We just don't take their word for it when we do control testing. And then we don't test all the, we don't protect all the system. But these are the different projects that we do. We do security control testing, private scanning, pen testing, incident management, to achieve the CIA of the system. But we don't protect all the systems, the organization. We will protect mission critical systems, systems that are used for the mission of the organization, like for instance, is a bank, or the banking software system that they use to process customer transaction is mission critical. If it's at a full retailer, all those systems that used to process customers' sales, menu and all that, those are mission critical. Without which they cannot function. Those are mission critical systems. We protect them, and any system that contains sensitive information, that contains PII, personally identified information, like social security number, credit card number, driver license number, all those are sensitive information. They need to protect it. There will be any system that contains those or that are mission critical will be shared out among the cybersecurity professionals in that organization for protection purpose. So, so that we can monitor them and make sure that there's no attack going on them. So our job titles are such that we are called IT security analyst, information security analyst, cyber security analyst. It means something. IT security engineer means in addition to detecting issues, security issues, you can also fix it. You have system administrative skills. I'm going to teach you that as well. So in that case, you are called cybersecurity engineer, but you can also fix the problem. You have admin system admin skills. Okay, and I'm going to teach you how to do that too. So security risk analyst, security auditor, or security control assessor. Security control assessor is the one doing security control testing here. This project. And then vulnerability information assurance officer or vulnerability scanning analyst or vulnerability analyst. These vulnerability analysts are the one doing vulnerability scanning here. They use tools. They run tools on the system to detect any vulnerabilities that it may have. Then we have compliance analyst who is making sure that everything is done correctly, or governance risk and compliance analyst, GRC analyst. They're just making sure compliance is followed by the organization. And then we have penetration testers these are the ones hacking the system. They do want to do penetration testing. And information system security officer, ISSO, is the point of contact for cybersecurity for the system. Okay, we'll soon be done here. That's the ISSO. So the ISSO is the point of contact for security. And they're like cybersecurity project manager for their systems. When it comes to security, they are the go-to person. But they also have security control assessors assessing their system. So they have compliance analysts checking on them, checking on their work. But they are the go-to person for security. They're the one that call the attention of different stakeholders to come and do their own work when it comes to security. When it comes to if there's a programming change on the system, ISSO will call the programmer to come and do their work. So database, issue on the system, the ISSO will call the database DBA to come and do their work. They are the go-to person. There's also poor management analysts. If there's issues on the system, they're the one that come up with how to fix it. Or they don't need to fix it, but they come up with how to fix it. Plan of action and milestones. One. Incident response analyst or intrusion analyst or intrusion detection analyst or SOC analyst. Those are the, if you want to do incident management, they're the one that monitor the network against attack, and they will remove the attackers if any exist on the network, on the system. They're the SOC analyst. There's forensic analyst that will confirm, investigate what has happened. If there's an attack, investigate what happened. How did it happen? How can we prevent future attacks? They do forensic investigation. So these are different job titles we go by. We do different things. but they are all cybersecurity roles. You find yourself doing one of them, but I will teach you all of them so that you can function in any of those cybersecurity roles. Because the more you know, the more opportunities you're going to have on the job. Employers like you to know more than one thing, more than one area. Even though they want to hire you for one area, you want to know more than one areas. Okay, that's why we go through all of them in your class. You can function any of them by the time your class is done. Now, the projects are broken down into like three. We have this assessment authorization project. It used to be called certification and accreditation. We assess the system and then we get authorization for it. We assess the system, then the system will be authorized to operate by a management, by management person at the organization based on an assessment report. So this is done every 3 years in the government space. Commercial also does it as a matter of best practice. Now, before any system can go live, it must be assessed by cybersecurity people. And then it's issued authorization to operate, license to operate it. So on this project, the assessment task is, this assessment is A to C. When we are assessing the system, we do security control testing. Assessor will work, assess it. Vulnerability scanning will be done by vulnerability analyst. Penetration testing will be done by penetration tester. If the system is a local area network, LAN, or is a web application, LAN is anything, the IT infrastructure, database, operating system, network devices. If it's any of those, we'll do pen testing on it. If it's a web application available online, we'll do pen testing on it. Those are the two sources that attackers come in. But if it's a system that is just an application within the network, we don't need to do pen testing for that. It's only when it's at the perimeter, entry point of the system, of the network, or if it's online, we need to do pen testing for it. And then once we've done that as an assessment, then the authorization will be issued by management level person, designated official, to operate the system for the next 3 years based on assessment report. That's a project that we do. Another project we serve as, we maintain the organization's security program in the role of an ISSO. Make sure security program is running for our systems. Everything that's due is done. If it needs to be program is done. If it needs to be patched, is done. And policy and procedures are in place. Those are supporting security program. ISSO does that. That information system security officer I talk about, go-to person for security. They will do incident management. There's a SOC analyst work, security operations center analyst work, who is monitoring for forensic analyst work, who is monitoring for security incident and remove incident from the network. So, and everything we do, these are projects. I can see different roles fit into those tasks. Now, everything we do is guided. We have framework that we follow. Now, but there's a law that mandates security in the government space. It's called FISMA, Federal Information Security Management Act of 2002. It says security must be done in the government space. Systems should be protected. And it was updated in 2014 as Federal Information Security Modernization Act. It's also called FISMA. That FISMA law mandates security protection in the government space. Commercial also protect their system because they don't want to be attacked. A lot of times they just follow what the government does as a best practice. So, that law is one that says A and A must be done. That's an authorization that I was talking about here. Before a system goes live, or every 3 years, it must be done. And then the guidance that we use typically come from NIST. So, for instance, I said if we need to test controls. There's a list of controls we expect for every system for them to be secured. There's a guide for those. Those guidance come from NIST, National Institute of Standard and Technology. These are part of Commerce Department. They provide security guidance or framework or standard. for us to follow. So we don't have to guess things. They have special publication, which are detailed. They have FIPS, which are summary level documents. They are part of that, and I said, do not print them out. Yeah. These publications, because they are large. See the special publication right here. You know, is this is special publication. Let me show you this current one now. This is special publication, date 2053, and it's from National Institute of Standards and Technology NIST, which is part of the Department of Commerce. But see, this one has 483 pages. But you see, the FIPS of it is a summary one. It doesn't go into details like this special publication does. So, for instance, this one has a list of the controls that we expect. Controls. See, you may not see them clearly here, but you know, controls. See, you can see the list of controls. These are just examples of what we expect. So they have them. For instance, we need to have policy and procedures in place for our systems. Okay, things like that. But now, special publication will go to those kind of details, how to do it. But the FIPS will just say we need to have controls. It will not go into details. That's why they are summary. The FIPS are FIPS. They are not a lot. They are not many. They are not many pages. So it's just 13 pages. The special publication that goes to the details. Okay, so we have guidance like this. We'll use it during your class. You'll see how we use it. You know, and the assessment part of the A&A project is also called security control assessment, SCA. This is the license, the authorization part, ATO, that is granted for that system for the next 3 years. The IT infrastructure and the government space for general support system, but they are not the main business software. The supporting infrastructure. That's why they call supporting general support system. These are just local area network stuff, GSS. So that's security program support that I'm talking about, done by SSO, incident response, done by SOC analysts using IDS, IPS, and all that. Again, the IT professional perform roles like security control assessor, ISSO, compliance analyst, GRC analyst, power management analyst, SOC vulnerability analyst, SOC analyst, forensic analyst, pen tester. All these are roles we talked about before, which we are going to cover in your class, so you can know all of them and function in any of those roles. They are all cybersecurity roles. We just do slightly different things. Okay, and now, like any project, we do planning. We plan what we want to do. We go out and execute fieldwork. We report what is missing. We already know the expectations, security expectations. If any of them is missing, they go into our report so they can be fixed. Then we follow up to make sure they have been correct. Issues have been corrected. So typical, things we do on our projects. So, and we will use framework. we use, NIS 2023, when, like the one I show you for the government, we use SANS 20 critical security control, SANS 20 critical security control for commercial, it was developed, created by SANS Institute. We also use ISO 7001 for multinational organization, like companies that are outside the United States, they're in Europe, they're in UK, or they have affiliation or head offices outside the United States. We can use this one. But the government one, NIS 2023, can be used by anyone, is the best practice. But commercial can use 20 out of it. Focus on those. They don't want to deal with all the government stuff. And then multinational can focus on this. They are just subset of the government stuff. So you see, we'll spend a lot of time looking at the government, and then you can easily understand the commercial and the multinational ones, because they are just subset of the government one. So, and the government has the best practices in cybersecurity. They do more things than commercial does and multinational does. By the time your class is done, you'll be able to function in a government environment, in the commercial environment, and also in multinational environment. We'll go through, we'll use your framework and all that. So for this commercial one that use SANS 20, the SANS Institute that created it for them they already handed it over to Center for Internet Security, Center for Internet CIS, to keep it up to date, to keep those 20 controls up to date. So that's why it's also called CIS Critical Security Control. So it's called SANS 20 Critical Security Controls, or it's called CIS Critical Security Control. It means the same thing. So we'll use all those frameworks, you see how they work, so that you can function in any environment you find yourself on the job.